So welcome to all the panelists. I think interop is probably one of the most consequential aspects of the crypto space. And we have some of the leading minds here and leading projects that are building real solutions to, I think, one of the most important problems. And so I want to make sure that we go around at the beginning for everyone to hear from each of these projects, understand where they're coming from, what they're trying to solve, and then we'll get into some specifics. As a quick background, I just want to tell you guys about Borderless and myself and why I actually decided to moderate this panel. So Borderless is a VC fund. There are many VC funds out there. One of the things that we feel very strongly about is that there is just too much fragmentation in crypto. And we think that the outcome and the negative consequences of that are felt by users, developers, and the space at large. We believe that fragmentation is one of the negative or it's like the flip side of rapid innovation. And we're committed to backing solutions and founders that are helping to address that and take us to the next level of adoption. So Borderless has, I would say at this point, the only fund of its kind. It's called the Cross-Chain Ecosystem Fund. I lead that fund at Borderless. We have over 20 layer ones as LPs in the fund, and they've all come around to the concept that aggregation is important to any chain, not just to one particular chain or, let's say, users or end users or developers, but each ecosystem itself benefits from having better underlying interop and secure connectivity. I think that what we hear on this panel, I think, should inform how a lot of people think about interop going forward. So let me just hand it off to everybody. We could start with Grigori and then go down from there. Thanks.
Hello, I'm Grigore Roșu. I'm the founder and CEO of Pi Squared. And our mission at Pi Squared is to bring the millions of Web2 developers to Web3. How? By providing all the programming languages and the VMs they need for their smart contracts in Web3. We think that programming language should not be a limiting factor anymore. Should not be a factor at all, actually, anymore.
Hey, everybody. I'm Magnus, or Magmar, as I often go by. I'm one of the co-CEOs of the Interchain Labs, which is essentially the main foundation and related entity that builds all of Cosmos. So if you're familiar with Cosmos SDK or Comet BFT, and then probably most relevant for this panel is IBC, which is a long-standing interop protocol that's done a significant amount of volume and powers roughly 150 chains.
Hey everyone, I'm Jason. I'm a co-founder at Reservoir, and one of our main products is Relay. I think simply, Relay is an intent-based bridge. We have an app and an API that lets you do bridging, cross-chain swaps, cross-chain calls across sort of 65-ish chains, including Solana, a bunch of EVM chains, Bitcoin. And this is built on top of our own in-house solver that holds liquidity across chains and allows you to move between chains very quickly.
Hey everyone, my name is Katya. I'm the head of growth at Wormhole Foundation. Wormhole is a leading interoperability protocol. We've been around for many years now. We were initially built as the bridge between Solana and Ethereum and have since expanded our support to, I think we're at 50 chains right now. We facilitate the transfer of assets, but also general message passing across the ecosystem. Today, actually, we just announced our settlement product. So we just launched a massive intents-based protocol, which will allow for any-to-any swaps in sub-finality time. So, we do the slow bridging, but we also can go really fast now.
All right, thank you all. So, let's get into some of the key things that I think you guys are trying to address. So, a couple of years back, there were views that we wouldn't have so many chains. We would have several chains, maybe, but that there would be, dominant ecosystems. And what we see now is that there's just a variety of different paradigms now, right? We have layer 1, layer 2, layer 3s, like layer X level of kind of abstraction and layer and kind of complexity. Then we have monolithic chains, we have app chains, we have innovation within each of these virtual machine environments that are creating new kind of architecture. How do you guys see this playing out in terms as projects that are trying to solve for interop, right? Because there's a lot of innovation happening even within particular EVM engineering communities. So how do you guys address that as a protocol or as a project that's trying to bring these or solve for interop across these? Maybe, yeah, you can start.
Yeah, I can speak to a little bit. I mean, I think something that perhaps early crypto stacks under-indexed on was, I like to fondly call it delusions of grandeur. And what I mean by that is the more sovereign the stack, seemingly the more attractive over time. And so I think one of the things that I would argue is almost like a anomaly is the fact that people continue to build more L1s and seemingly at a faster and faster pace. I think the reason for that is because the most valuable things in crypto are L1s, right? And everyone telling you to build an L2 is probably an L1 themselves. And so I think people tend to gravitate towards that. And I think that's not going to slow down. One of the things that, just speaking from the Cosmos side, which even back in 2017 believed in this concept, its tagline is the Internet of Blockchains, is that interoperability is going to be a huge problem between them. And it baked in an interop solution into the actual chains themselves, which is called IBC, which is a light client verification protocol that goes point to point. And that, I think in many ways, has just made interop not an issue in the Cosmos ecosystem, even though these are fully sovereign L1s with their own consensus, just like Aptos or Sui or Ethereum or Bitcoin. One of the things that I would love to see, that I would be very excited to see, is sort of the expansion of an interop protocol at that level for the other multi-chain stacks.
Yeah, that's an interesting point. I do think that people are still trying to innovate on the blockchain level, but I also am seeing a lot of success within the OP ecosystem and with the superchain. Similarly, with the Arbitrum Orbit ecosystem, it seems like people don't really want that headache of having to build custom contracts. I think right now, as we start to see more multi-chain protocols want to deploy on more networks, you can't keep messing around with the core contracts to be able to do it. So I think teams want to be able to be as plug and play in the existing ecosystem as possible. At least that's what we've been seeing with Base and now with Ink and dozens more coming online to the super chain. But the way that we're handling it right now is we're becoming more modular. So we understand that right now for you to get a complete deployment of Wormhole on your chain, we have to have 19 validators, set up shop, run nodes, and then communicate between all of the different supported networks. That's a really strong security model, but we also understand that some teams don't need such a high level of security. And so we recently launched, actually a year ago now, our native token transfers framework. It allows for a more modular asset transfer. So you can use the Wormhole Guardians where available, but you can also build your own verifier and then use whatever security model you want to be using to get there. So some people like a 2 of 2 multisig. Some prefer, a stronger security model. And so I think as, we start to see which of these long tail chains do well, it's a great opportunity, for us to see where demand is and then be able to expand there.
I guess I would just add that, I mostly think we should avoid hardening at any layer yet. It sort of feels to me like we still haven't reached escape velocity, as an industry. So I sort of think of myself as a blockchain pluralist. I really want people to just be able to try every application. The use cases that we're looking for are not use cases where people care about the underlying technology. They're applications that people actually want to use every day. And so for me, we should be very pro innovation, very pro trying new things at every layer of the stack until we really feel like we've figured out what works. Because I think generally speaking, I would argue that we still haven't.
All right. So besides everything that was said, which I fully agree with, let me also tell you our approach to interoperability and reducing fragmentation is what we call universality with respect to programming languages. And instead of translating programs to particular VMs, what we decided to do is to use programming language semantics which is a mathematical definition actually of the programming language, is the common language across all the different languages and systems. Mathematics hasn't changed for a long time, thousands of years. So by being able to automatically, and that's what we do at PySquare, we automatically convert any computation, any execution in any programming language to a mathematical proof. For us, the execution of a program is a constructive way to obtain a mathematical proof that Alice transferred one token to Bob, for example. There is a rigorous mathematical proof underneath. And the nice thing about mathematics is that you get compositionality, interoperability, basically for free. Because in mathematics, you can prove a lemma and use it to prove another lemma and use both lemmas to prove a theorem. For us, calling a function in Rust, which calls a function in EVM, which returns a result to a WASM program, is just putting different mathematical facts together in the same universe. And if this works, it's great. The question, does it work? And that's what we are trying to do, to make it work. And that means specifically to generate all these mathematical proofs completely automatically under the hood. As soon as a user has to interact with proofs, the game is over. So,
Could I just ask you a quick question?
yes.
How does that like is that useful for interop in some way as well, or?
Yes, because if you have, actually, we just gave a demo 1 hour ago showing that. Because now once you have, from one language, you call a function in another language, let's say, right? So they have to agree on the storage representation, but then once they do that, then how each of them performs the computation is how you have many different ways to prove a mathematical fact, a lemma. But once it's proved, I can use it. I don't care how it was proved. I don't care if it was proved using the WASM semantics or if it was proved using the EVM semantics. I know it's true. Computationally true, it's a fact. Now I can use it.
Yeah, thanks. So I think what's interesting is, yeah, I'm familiar with all the projects here on stage, and I think what's as a VC, just on the VC hat side, it's like honestly the problem of fragmentation across ecosystems we see replicated in like interop, because there's just so many ways. There's kind of different ways, not so many, but there's many ways to solve this that you could potentially defend. Like either you could optimize for security, you could optimize for, provability, you could optimize for efficiency, different ways you could decide, something is more or less important. It's all about trade-offs. So given that all of you guys are in the business of interop, and I think that that's actually core to pretty much all what you guys are building, how do you guys view standardization, right, as being kind of relevant to your roadmap? Because, yeah, I mean, ecosystems will come and maybe some will go, but we will continue to see more and more chains, right? Maybe we won't see the same ones persist, but interop is going to become, I mean, we can't continuously, or do you expect to see that we will continue to see more and more evolution in interop standards, or at least, or maybe non-standard, right? I guess it would be helpful to understand, how do you guys view standardization versus non-standardization going forward?
So we love standardization because a standard is for us a formal specification describing very clearly what needs to be done, how things need to be connected, and yeah, we just don't propose any standard ourselves yet, at least. But we have some standards for storage, how to access, how to read, write data, but that's very low level. But standards are great. I think standards are great. And moreover, I think we need to formalize them, to have formal specifications of the standards. Why? Because then we can use them to prove properties about interoperable systems. Otherwise, how can we prove anything? How can we claim any correctness? So,
Yeah, I was on a panel about interop standards with Layer 0 and Axelar, and it was very funny because everyone agreed that there should be standards, but everyone agreed that it should be their standard, right?
I don't.
I mean, I respect that. There's massive, so part of it, in my opinion, is that interop is financialized, right? What you choose for interop protocol at the end of the day is a financial decision to some degree, right? And there are, what funds, the different interop protocols to, be here is that there is some layer of financialization, which I don't think is bad. right? That's actually what pushes things to be more successful. But there is huge financial upside to owning a standard. And I think right now one of the issues that I see in Ethereum with the L2 ecosystem is standards are coming as an afterthought, as opposed to a pre-thought, which just makes it quite challenging, right? But it also means that when you don't have standards, you get a lot more innovation, right? So I would view one of the greatest innovations of bridges recently that you were mentioning too with Wormhole is the transition from bridging to GMP protocols, or general message passing. Sorry. The reason I think those are probably the future is because increasingly people want more control over their issuance. And if we enshrined a standard 10 years ago or 5 years ago, like who knows what we would have created. And so I think right now we're actually at a period of really good competition where different people are heavily incentivized to compete. And a lot of that competition I see is not just coming out on the BD side or the incentive side, it's actually coming out on the protocol design side, which ultimately I do believe that these things will eventually converge. But at least from our side on the building IBC, it's something that actually is much more collaborative than competitive. Like we're looking at Wormhole, we're looking at Axelar, we're looking at Layer 0 and trying to understand, okay, what parts of these are actually very good, right, and what parts of these are gated. Just the last thing I would say is the one thing that I do find very concerning is exclusive lock-ins, which I see increasingly, and those make me very sad because oftentimes I'll talk to chains that want to use something more open or permissionless, but they're locked in. This is something I'd love to not see happen in the future, but yeah.
I think that's a overall really great take. And maybe I'm just a little bit, I'm not sure bitter is the right word, but as a solver, seeing some of the standards like 7683, which I think my perspective would be it's a standard and it's too early to standardize, right? So it's a standard that basically is so broad as to be applicable in all circumstances without actually doing anything useful, right? So from my perspective, when you look at intent-based bridges, we're actually too early to be standardizing. What we want to be doing is actually continuing to compete, building great solvers, building great intent-based bridges, and then maybe you get to a place where it starts to make sense to harden things a little bit. And so I think it's kind of this fine line, right? You want competition, you ultimately want to get to a place where there are standards, where there's more openness. And I would say that I think it's great to see on message passing. I think on the intent-based bridge side, I think maybe we're starting a little bit too early.
Yeah, I'm fully in line with this. And to your point, though, it's what motivation does Ethereum Foundation have to fund this standard, right? Are they going to continue building tools on top of it, right? I think it's pretty great to see so much competition on the standardization level. Obviously, I'm a little biased. We've got our own token standard, but even in the way that we think about building our token standard, it's not lock-in, right? We would love for you to use Wormhole Guardians to power your messaging. But if at some point, a great ZK-like client gets introduced, you can swap that in and swap Wormhole Guardians out, right? I think giving the ownership and flexibility in how these standards are developed is really critical. And I take a lot of pride in the way that we've designed our token standard. And I really want to see that continue to be the direction that all of these interoperability providers continue to move down on. I think Wormhole Guardians is an exceptional, best in class security model. BlackRock uses it to secure the transfer of their BUIDL fund. Apollo's ACRED, tons of institutions see this as, the highest standard of security. But we also know that on the GMP level, that innovation is continuing to happen. And so we want to make sure that, we can future-proof all of these assets and allow for the flexibility for new verifiers to be plugged in. And I think broadly, that's also how we're starting to think about the Wormhole protocol more generally. But to start, NTT is the way that we're doing it today.
Maybe I'll go around the room on an open question. Given that some of you guys have been in this space for a very long time, right? I mean, that's why I think it should be noted, for the audience, that these are people that have been working on this for a long time. I mean, Grigory didn't necessarily have Pi Squared, but he's been in the space for such a long time with runtime verification. You know, I think it would be great to get your view, not necessarily the state of play right now, but let's say like 2 years down the line. What do you think is the most important role for interop technology? There's several things going on, right? There's general message passing, there's liquidity, there's execution, there's various things that could be done in a way that's cross-chain or multi-chain. What do you think is the future? Like, where do you see these things converging? And I understand, I understand the underlying point that, interop protocols want their protocol and their approach to become the standard. But beyond just what we see right now, everyone has their roadmaps, right? Where do you see things going like 2 years from now, let's say?
Can I go last?
Sure, we can start at the end there.
Can I go second to last?
Oh God. Man, oh man, that's a tough question. I mean, ideally, I think our brand is awesome. I would love for nobody to really know what Wormhole is or what it does or have to like make a decision, to use Wormhole assets versus anything else. I think people should just have it running in the background and not even know that it's, an active decision that's being made, and really only asset issuers and protocols should ever have exposure to Wormhole. That's, I think, the general direction I would love to see.
I guess if I had one rule right now, I would say it's UX above everything else. I think for us, we're really trying to push the user experience of interacting on chain to a point where it's comparable to what it's like to interact in Web 2. When we started building Relay, which was, just a year ago, a fast bridge was like 8 minutes. And now, a slow bridge is 8 minutes and a fast bridge is, 3 seconds. And so I think things are really evolving quickly. And we're getting to a point where you can start to experience blockchains in a way that feels a lot like just being on the internet. And I think we just need to continue to push there. Like, at least that's what our focus is, right? And I think part of that, to be fair, is because there's lots of great people on this stage working at a different layer of the stack. And I think what we saw was just an opportunity to like really crank on that dial and see how far we can get to try to like build great applications that just like feel buttery for people.
Yeah. I guess I mostly agree with Jason. Like, we've already like gone so far, right? Where we've improved so much. Like, I'm just thinking about the bridging experience I had. My introduction to crypto was with Terra Luna, unfortunately. And Wormhole was very different back then. Very different. It was not the best experience. Much better now. Using the interop protocols of today, honestly, it's completely different, right? And I think we've seen so much innovation on that side, making UX really seamless. I think one of the big issues that, not a lot of people are talking about, that is honestly something that comes up a lot when I look at different ecosystems is concentration of liquidity. So, one thing that we really haven't solved yet is how to make an actual multi-chain app, right? That is not centered in one place, where it pulls liquidity from different places, right? Because part of that reason is the movement of liquidity is still extremely expensive. Even at $1, it's quite expensive if you sort of wanted to have something be very seamless. And it does not compete with like synchronous composability on 1L1. I don't know exactly how to solve this, but this is something that I see a lot, right? It's like, how fast can you make async so that it actually can catch up to sync, and you can or be sort of incomparable or comparable. And once we get there, I think we'll see an explosion of applications that are going to be much more multi-chain. Yeah, the only thing I can think of right now is like Kaido is sort of this way, right? It's like not attached from an ecosystem. It sort of just exists and like uses different application state layers, different places. I'd really love to see more of these.
Now you're up.
What was the question again? So going back to the original theme of Pi Squared, you mentioned runtime verification. Yeah, I founded runtime verification in 2010. We didn't even have blockchains as we know them now. And then in 2017, we started auditing security audits. What we developed was formal semantics, formal verification technology, how to prove things correct. And we worked with NASA, Boeing, and then we started with blockchain in 2017. And as part of that, we defined many, we're talking about standards, many formalizations of standards, because they are extremely important, necessary to do formal verification, to do proofs of correctness. And I'm also a professor, actually, of computer science at UIUC. And in my department, LLVM was invented in our department. So we have a lot of experience with programming languages and compilers and VMs. And I got to a point now, that's why I started PySquared, where I believe that we don't need to implement programming languages. We don't need VMs to power blockchains. We can do the computation off-chain and separate concerns, reduce computation to mathematical proof, so we don't have to worry anymore about the correctness of the compiler, of the interpreter. We take that off our shoulders. And of course, we still need standards. I don't want to, to imply that. For us, even a programming language is a standard. The formal semantics of the programming language is the standard, right? And once you have a mathematical proof, you can check it. And now you know that the computation was done correctly. And you can settle that computation once and for all. And it doesn't have to be on a chain. It can be on some other sort of settlement layer that anybody can use as a truth. And I think that will help a lot with interoperability. And by the way, I didn't mention ZK proofs at all on purpose, because ZK proofs should come after. What happens now is a big mix of programming language semantics with compilers, with cryptography, with a VM, with polynomials for each low-level instruction, reading, writing memory. So computation with cryptography are mixed all together. And in my opinion, what we got is a big mess, which, if anything is certain, is that they have lots of errors. Okay? By separating mathematical correctness from cryptography, I think we can get everything we need for ultimate interoperability, because we can have these claims, computational claims, which have been proved once and for all. Alternatively, I can also get a ZK proof for it by checking the mathematical proof with a circuit, or maybe a TEE proof is good enough, or maybe a multi-sig proof is good enough. And that claim now can be used. You can take a proof of that existence, a proof of truthness of the claim, and use it on any chain. So you can generate claims from any chain, or even applications which are not even on chain, like a high-speed trading platform, can live by itself and settle claims, and then you can use those claims on different chains to, for example, move liquidity. Anyway, what I'm getting to is that I believe that mathematics can do a lot for interoperability with or without ZK proofs.
No, thanks for that. Actually, it gets to a really important point, which is that for a long time, and even up until today, there's like a specter over bridging and interop, which is just security. And basically, this concept that it's just not secure enough. So that's why we don't see as much progress in the scaling of this. You could make a counter argument that has more to do with cost and efficiency, and that's why you see more things happening within one chain. I think security, though, still hangs pretty large above the whole bridging interop world. And I think Grigore brings up like an important point, right? Because he's coming from a kind of fundamentals basis on provability. Now that you spoke on that, I just want to give others a bit of a chance. We have like a little bit of time to just talk a little bit about security and where you see that playing an important role in what you're building. Any of you guys can speak on it. Yeah.
I maybe have an interesting perspective here, because fundamentally Relay today is basically centralized, right? And so I think a couple points I'd like to make. I mean, one is, I think maybe people do a bit of a miscalculation, or there's a bit of a miscalculation in terms of how we should be thinking about security. If you come to Relay and you use us today, you trust us for 3 seconds. If you get an asset that has a token standard built into it, a bridge basically built into the token standard. Yes, maybe that is a higher level of security, but it lives in your wallet for like the entirety of the time it's in your wallet. So I think sometimes what we see is actually that um, there's different ranges over which you actually have risk associated with a sort of interop. And I think in one direction, we're seeing like, Mint, burn and mint bridging becoming like much more dominant in the space. And I think maybe people actually underestimate the security risk there. Like, we trust all of the teams, but you see something like Bybit happen and you kind of wonder to yourself, do people really understand that every time I have, a multi-chain token in my wallet that I am basically, it's as good as having a bridge position. So I think that's something that like we notice, right? Like I think early days we thought people would be more concerned about using Relay. And actually people like the fact that it's like, okay, 3 seconds, I'm done. Now I have only the security of the chain to worry about. Would be kind of curious your thoughts with like NTT and some of the other token standards, like how you think about kind of like that stacked risk.
Yeah, I think it's an interesting point. It's an interesting discussion to have, which I'm really sorry we don't have much more time left. I think there's a lot of GMPs that are still a 2 of 2 multisig, and so that risk sitting in your wallet is scary.
Name them.
Pardon?
Name them.
But I think, that was actually going to be my hot take, is that people actually like do care about security and the duration of that security. That's why we take so much pride in the Wormhole Guardians, and that's why we're spending a lot of time funding ZK work, because that is a zero risk that, we're always introducing into billions of dollars that are secured by NTT. And so we're very confident in the system that we have today, and we're always working to make, gradual improvements on it. But I think really, like, when you look at these institutions, like, they really don't have the space for, reckless security and reckless, like, regulatory compliance. So yeah, I'm fully with you. I think intense solutions are really interesting. But ultimately, you're still going to be transferring these NTT assets, these OFT assets, ITS through your network. And so I think maybe it even compounds a little bit, but that might be a separate discussion then.
Yeah, I sort of have similar viewpoint to you guys, which is like intents were able to develop because you have secure bridges, right? So if everyone was getting their bridges hacked, like market makers wouldn't even participate. They'd be like, I'm going to wait for the full finality, right? And you're going to charge me a premium on top of that. I think one of the things that I see a lot is a lot of desire for customization in terms of security, right? It no longer feels like there's one size fits all. And for example, I was at the Ondo Summit, and they're launching a chain on top of Cosmos technology. And one of the things they liked was that they could use their own validator set for their own signing set, right? And so I think, and to my understanding, wasn't that they wanted that; it's that they had to have that, right? And like I view this as probably just the beginning of what is eventually going to happen, which is people are going to want to have their own security assumptions, whether those are 2 of 2 multi-sigs or not. And so, what I imagine seeing is a lot of flexibility around that. And I already see sort of like Wormhole, other bridging protocols adopting that. In the case of IBC, it's your own validator set, right? That does that. It's your own validator set, and it's your same stake that signs the transaction and validates the validity of the bridge. One of the things that this is a little bit of a shill that I'm really excited about is IBC has sort of lived in its own bubble for a long time within the Cosmos ecosystem. Come March 27th, it's going to IBC v2 is coming out, which natively interoperates with Ethereum and any other smart contract platform, Solana, Aptos, Sui, and has the same security assumptions. I'm very partial to IBC as a foundation because it's open permissionless, and one of the things that I'd love to do is to work with folks like you guys. And I didn't understand a lot of what you said because it's very mathematical, but to sort of like build on top of that.
Awesome. All right. Thank you all. We're definitely over time. And I think, like I said, this is an amazing group of founders and builders in the space, I think, and appreciate all the things you guys shared today. Thank you.